Guys, today, lesson 56, we're going to be learning to write and identify direct variation. Now, direct variation, if we're going to learn to write this and identify it, we have to know what it is, right? So we would expect that the first question we would need to answer here is, what is direct variation?
Variation that's direct.
Variation that is direct. And it does really describe what we're talking about. Y varies directly with X. And direct variation is a relationship between X and Y that can be, now the key word there is bold, or the key phrase, it can be written as Y equals MX. Now, Y equals MX looks very much like something we're used to working with, right? What does it look like? It is actually Y equals MX plus B, but B is equal to 0, right? So this is something that is just a special type of linear equation. Y equals a number times X, okay? So direct variation is going to always be written as Y equals M times X. So direct variation is literally a line with a y-intercept of 0. I guess we really probably should say a non-vertical line. Those vertical lines are not direct variation. Vertical lines do not have a y. Okay, so it has to be between x and y. It has to be an x and a y. Vertical lines do not have an x and a y. They have only an x. So y equals mx, it's a non-vertical line with a y-intercept of 0 is a direct variation equation. Now we can look at this as an equation. We can look at it as a set of ordered pairs. We could look at it as a table. We could look at it as a written scenario. All right, so we'll have a look at a few of those things. Now, tell whether each equation represents a direct variation. If it is a direct variation, find the constant of variation. Now, the constant of variation, find the constant of variation, that's telling us to find out what m is equal to. All right? So y equals mx, and what is the value of m? All right, so letter A, we have y plus 8x equals 0. Can this be written as y equals mx? Yes, how would we do that? Subtract 8x from both sides, and when we subtract 8x from both sides of the equation, we're left with y equals negative 8x. And our constant of variation, our m value, is negative 8. All right? Okay, so this is a pretty simple concept, right? It only gets confusing if you forget what direct variation means. So direct variation means it can be written as y equals m times x. All right, what about this next one? Can y over 10 equals x be written in a direct variation form as direct variation?
Yes.
How do we do that? If we have fractions in an equation, what are we going to do with those fractions? We're going to multiply by a common denominator to get rid of the fractions. We multiply this by 10, we get y equals 10x, which is certainly direct variation with a constant of variation of m equals 10. All right? Y equals 10x. Last one from this example. X times y equals 6. Can that be written as y equals a number times x? No, because if we put it in y equals form, we would have to divide by x, right? And we get y equals 6 divided by x. Y equals 6 divided by x is it's what we call inverse. It would be so nice if it was indirect. We would want it to be. It's inverse variation. Okay, x times y equals a number is inverse variation. So that's not direct variation. So the Our inverse variation constant or factor in this one would be 6, but that's not what we're doing. Inverse variation we'll look at next unit. Okay? All right, so tell whether this set of ordered pairs represents a direct variation. And if it does, I want us to actually write the direct variation relationship. Does this expression, or does this relation represent y equals some number times x?
Yeah.
Wait,
No, wait.
wait a minute. Yeah.
Yes. It was
Yes?
negative 7.
Yeah.
Yeah.
Y is equal to negative 7 times x. Yeah? Negative 7 times 2, negative 14. Negative 7 times 5, negative 35. Negative 7 times negative 3, positive 21. So y is equal to negative 7 times x in this relationship. So it is a direct variation relationship, or it represents a direct variation relationship. What about this one? Don't answer too quickly. Do the points 2, 4, 3, 5, and 5, 7 represent a direct variation? In other words, can we write an equation in the form y equals m times x that'll give us all three of those points?
I don't think so.
Well, obviously, the first one will almost fool you if you only look at that one, right? It would look like from this one that we were dealing with y equals 2 times x. But that doesn't work on the other one, does it? It doesn't work on this one. All right. Now, what relationship is in play here? X plus 2.
You can do that.
Yeah, but it's not a direct variation.
Okay.
So the answer here would still be no. Is it a linear relationship?
Yeah.
Yeah, but the y-intercept is 2, and that means it's not direct variation. What's the y-intercept of a direct variation relationship? 0. Now let me show you one other way that you can do this quickly.
Is it an inverse variation?
No, it's not an inverse variation. It's just a linear relationship.
Could you like look at, and what if you like, could you look at the slope? Because I don't know.
Well, the slope doesn't necessarily, looking only at the slope isn't going to help, because this has a slope, right, and it's not unique or anything distinct about it. But let's take, let me show you something. If we solve for m here, which is the constant of variation, how would you solve this equation right here? How would you solve that equation for m? Divide both sides by x. So if it's a direct variation, if we divide y by x, we're going to get the same number every time. So what is negative 14 divided by 2? What is negative 35 divided by 5? What is 21 divided by negative 3? So y divided by x is the same thing every time. 4 divided by 2 is 2. 5 divided by 3 is not 2. And so this is not a direct variation. All right? So that's one way that you can look at this thing. Direct variation is y divided by x is the same number every time. Inverse variation, when we have a look at that, it's going to be x times y equals the same number every time. And it's not going to be m. It's going to be k, because m is reserved for slope. And I don't really like this. Is not linear. Okay? It cannot be written as y equals mx plus b. Not linear. Okay? So what about this one? This problem is saying to write an equation for a direct variation. So they're telling us it's a direct variation that includes the point 624. Write an equation for a direct variation that includes the point 624. Mary Helen, what do you think it would be?
Wait,
All right, if it's a direct variation, we want it to be y equals something times x. Where do we find the m? How can we find the m? Remember, we just said that m is equal to y divided by x. Y divided by x is 4. So y equals 4x is what we're looking at here. 4 times 6 is 24. Direct variation. What's the relationship between y? Y varies directly with x. How does it vary? Y is 4 times x. Whatever x is, you multiply it by 4. That's why it's direct. Okay? Something that wasn't direct would be something like 4 times x plus 7. There's something else in play that's not direct. Okay? Example 4. The distance a person runs varies directly. Look at that. What does that tell us we're dealing with? Direct variation. What does that mean? Y equals mx. Whoa. Y equals mx is what we're looking at. Distance a person runs varies directly with the time spent running. Actually, the equation is D equals RT, right? That's direct variation. Distance varies directly with rate and time. Depends on how fast and for how long. It's direct, okay? If a person runs 12 miles in 2 hours, how many miles will the person run in 3 hours? Okay, so this is a direct variation, right? And the direct variation is really, it's D equals RT, but we could also write it as Y equals MX if we want to. What's the M value here? 6, because 12 divided by 2 is 6. And if X equals 3, then we're looking at 18 miles. Now, you could use logic to work this out, but this just kind of gives you a mathematical formula or equation that you could do to work it out. All right? It is a direct variation expression. Last one. The grocery store sells 3 pounds of lemons for $1. Graph the relationship and then use the graph to estimate the cost of 12 pounds of lemons. Now, I am going to go against the directions here because I do not think that graphing this is a clever way of doing it at all. Okay? First of all, we could just use logic and reasoning to do this, right? How much is 12 pounds going to cost? $4, right? Because 3 pounds 4 times. Right. We could also use a linear relationship, y equals 1/3 of x, where x is the number of pounds. And that's maybe what they want you to see graphically. If we looked at this graphically, it's not the screen I want. Yeah, you can see that. All right, if we looked at this graphically, and we take 0 pounds of lemons cost $0. 3 pounds of lemons cost $1, right? What's the slope? 1/3. The y-intercept is 0. So it is a direct variation equation. So, I could see some logic into using a graph there to write the equation, but you can also do 3 divided by 1, or 1 divided by 3, $1 per 3 pounds. That's 1/3 of $1 per pound, and then use the direct variation equation there. 1/3 of 12 pounds. Why in the world would somebody want to buy 12 pounds of lemons?
They're making lemonade.
That's a lot of lemonade.
Lemonade stand.
Yeah, maybe so. All right. So your homework is page 365, A through H, 1 through 10, 12, 14, 16, 17, 20, 21, 23, 29. for accuracy. This is lesson 56. Okay. Last night is for completion, lesson 55. But both of those are due tomorrow, and then we'll also cover lesson 57 for homework on this. That means probably, as early as next Friday, we could have a Unit 6 test.
Biology test on Friday. No, I don't.
All right. So if you guys will kind of keep that in mind. It's also next week, Spiritual Emphasis Week, so I'm not sure we're going to be able to kind of catch up.
Oh yeah.
Morning classes will be short.
Y'all have. I forgot. Oh wait.